In this session, we are going to evaluate the bearing capacity of uh, foundation in drained and undrained condition. For this purpose, we have to know more about drained and undrained condition. What is drained condition? In drained condition, we don't have volume change. In drained condition, we have volume changes in uh, pore water pressure. So we have excess pore water pressure, and uh, effective stress uh, is equal to total stress. These three conditions must be uh, available in drained condition. But in undrained condition, we don't have volume changes. Uh, we have excess pore water pressure, and effective stress is not equal to total stress. So these three conditions must be available to undrained condition. So to uh, for calculating the first model, we use the main model. Main model is MK water one. Uh, we consider this model layer one properties are gamma unsaturated 20, gamma saturated 22, and the situation is drain condition. The situation is drain condition, and the model constitutive model is more Coulomb, and everything is like that. And for mechanical, stiffness is 2000, Poisson's ratio is 0.35, uh, cohesion is 5 kilopascal, uh, friction angle is 31, and dilation is 1. And these are all the things that we must define. So are you okay that? And run the model. We tick the phases, run the model, we wait to finish calculation. Of course, the water table is in the ground surface in this example. And the situation is drain. We have drain condition. So we go to the output, view the calculation results, click on continue, and go to curve, click on the curve, and click on new, choose the node, choose deformation, total deformation, UZ, force, FZ, click on invert sign in both columns. Okay, so we can see that the bearing capacity is about 11,000, between 11 and 12,000 is bearing capacity. So we are going to compare this bearing capacity of drained condition with undrained condition. So we go to model the undrained condition. We close, yes. So we change the situation. We go to material set, layer one, layer one. We don't change anything except drainage type. We change drainage type to undrained condition. Of course, as you see, there are different undrained conditions. Undrained, as you see, there is undrained A, undrained B, and undrained C. There are some differences between these three options. Option one, undrained A. In option one, undrained A, we use effective parameters for stiffness and strength parameters. For example, for deformation, we must use stiffness parameters like E and Poisson's ratio. So these parameters must be effective parameters in undrained A. And also for strength parameters that, for example, are cohesion and friction angle, uh, these parameters must be effective parameters too for undrained A. But for undrained B, uh, stiffness parameters must be effective uh, and strength parameters must be total parameters, not effective parameters. This is difference between undrained A and undrained B. But in undrained C, both parameters for stiffness and for strength parameters must be total parameters. So this is difference between undrained A, undrained B, and undrained C. But uh, for choosing appropriate option, we must know more about these options. For option A, Android A, uh, uh, the situation is undrained, but we use effective stress because during the calculation, uh, um, excess pore water pressure is calculated, and based on that, effective stress will be calculated, and uh, with effective stresses, uh, deformation and strength will be calculated. So everything is based on effective stresses. Uh, but in undrained B, uh, again, excess pore water pressure is calculated, and based on that, effective stresses will be calculated. But effective stresses are used for calculating deformation only. And for calculating stresses, we use total stress and total parameters. Total strength parameters and total stress are used for calculating strength. In undrained C, uh, excess pore water pressure isn't calculated at all, and only we use uh, total parameters and total stresses to calculate both deformation and strength. This is main difference between these three options. So Which one is more suitable, more appropriate for us in this model? Something that we must consider is that in undrained condition, usually the purpose is calculating consolidation. But in this example, not. In this example, we are not going to calculate consolidation, but we must know that in undrained condition, usually we are going to calculate consolidation. So in consolidation mode, uh, we need to know the situation of the model during the time, because at the first of consolidation, the excess for water pressure is high, so uh, the effective stress is low, but during the time, excess for water pressure will be decreased, and uh, e- effective stress will increase. So the situation uh, changes during the time. And for consolidation, we need to know excess for example, excess for water pressure during the time. So because of that, we cannot use undrained C, for example, or undrained B, for example, because with this, in these two conditions, calculating the strength cannot be done correctly, because we cannot use excess for water pressure to calculate a strength in undrained B and undrained C. So if we want to calculate, we want to model consolidation, the best choice is undrained A, because we can calculate excess for water pressure during the time from the first of from the start of consolidation to the end of consolidation. So uh, for modeling of consolidation, the best choice is undrained A. But another thing that is important is that if we choose under A, we must choose an appropriate constitutive model to calculate excess pore water pressure correctly and exactly. For example, a hardening soil model is a suitable model that can calculate excess for water pressure correctly and exactly. But Moore Coulomb constitutive model is not a suitable model, because it cannot uh, calculate uh, excess for water pressure correctly and exactly during the consolidation. So if we use undrained A model, we must be aware of choosing appropriate constitutive model too. But here in this model, to calculate bearing capacity, the stiffness is not important and deformation is not important. So the key factor are related to strength parameters, C and phi, for example. And in this parameter, we can use, in this example, we can use undrained A, undrained B, and undrained C. If we use undrained A, we must use effective stresses for both stiffness and uh, strength parameters. If we use undrained B, we must use effective parameters for stiffness and total parameters for strength. And if we use undrained C, we must use total parameters for both stiffness and strength. So we choose undrained A, and